Hello, welcome back. Today let's solve Leetcode 153. Find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. So for example, the array 1, 2, 0, 1, 2, 4, 5, 6, 7 might becomes 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times, and if it was rotated 7 times it will be 0, 1, 2, 4, 5, 6 and 7. So rotated 7 times will becomes exactly the initial arrays. So okay, so the array nums only contains unique elements, so our task is return the minimum element of this array. Okay, so for this problem, when first read, is it might very an easy problem, right? Because we can easily solve it in O of n time complexity. We only need to loop for each element, for each number, and then we can compare the current number with the, the current minimum value, and then if it's less than the current minimum value we only need to update that. Okay, if do that, the time complexity is O of n, but for this problem it requires us to write an algorithm that runs in O of log n time. Okay, so for if the time complexity is O of log n time and the problem is a searching problem, so we already know that there is only one algorithm, I mean one searching algorithm that can run in O of log n time. So that is the binary search, right? The binary search, and then we can think about binary search to solve this problem. But how can we apply the binary search to the sorted array but it was rotated? Okay, let's see how can we apply binary search to this problem. Okay, so for example we have this array that is exactly the second example, 4, 5, 6, 7, 0, 1, 2. Okay. Okay, so as we already know, for binary search we will keep track for the 3 pointers, right? For the pointers at the beginning is the left pointer, the pointer at the end is the right pointer, and the pointer at the middle, it is the middle pointer. And then we will compare the element at the middle with the target, and then we can adjust the left pointer and the right pointer to eliminate the half of the array. Okay, so for this problem we will find the minimum elements of of the rotated array, right? So to do that we will need to compare the element at the middle with the element at the middle plus 1. So I think first of all we can easily to see we have an edge case that we can find the minimum elements of the array. That is if the element as the middle is greater than the element as the middle plus 1, since yes, and since the array is rotated, right? If the okay, so if the numbers at middle greater than nums at middle plus 1, okay, so the element as middle plus 1 is the minimum element, right? because 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 if the nums at middle plus 1 is less than the nums at middle, it means the numbers at middle is the largest element in the rotated array. Then the nums at middle plus 1 is the minimum value, right? Okay, so what if the nums at the middle element is less than the nums at middle plus 1? Okay, well, let me give another example. Okay, so same as this array, but if it was rotated like this, right? So now we have the left pointer here, the right pointer here, right? And the middle pointer is here, right? Okay, and now we can see that the number at middle, we will not compare with the numbers at middle plus 1 anymore, but we will compare with the number at middle minus 1, the previous element. Then if it's less than, so we can return the nums at middle, right? Because if this condition is satisfied, it means the nums at middle plus the nums at middle minus 1 is the largest element of this array, and the nums at the middle element is the minimum element. Okay, and okay, so for other cases we can check. So left is here and right is here, so same as this array, but if it's rotated like that, and so now both two S cases are not satisfied, so we will need to do something, and then what we do, we will compare the middle element with the first element, right? With the first element of the array, and then we will compare if nums at middle, if it less than the nums at 0, so it means, so for example like this, if the nums at middle is less than the nums at 0, so it means if the minimum element only exists in the first half of the array, right? And then we can eliminate the remaining array, right? We don't need to care about that, right? So if this satisfies, what we do, we will update the right. Okay, right is middle minus 1, else we update the left pointer to middle plus 1. Okay, so that's all for the idea. Okay, so I think we can dive to the implementation. Okay, okay. So first of all, let's see about the constraints. Okay, the maximum length is 5,000 and minimum is 1. Okay, okay. So I think we have one edge case, right? If nums dot length is 1, we can return nums at 0. Okay, and okay, so if nums dot length is equal to 2, so we only need to compare two elements, right? Compare two elements, mean nums 0 and nums at 1. Okay, okay. Otherwise we will do the binary search that we already discussed here. We need three pointers, right? Left, right, and middle. Okay, left 0, right nums length -1. Okay, so while left less than right, we have middle is equal to left plus right divided by 2. And then if, okay, the first condition is if the nums at middle greater than the nums at middle plus 1, right? Okay, so we have nums at middle greater than nums at middle plus 1. Okay, so we can return nums at middle plus 1, right? Okay, the second condition is if nums at middle less than nums at middle minus 1, we will return nums at middle, right? If nums at middle less than nums at middle minus 1, we will return nums at middle. Okay, okay. So for other case, we will compare the middle element with the first element. Okay, we will compare if nums at middle, if it's less than, right? If it's less than nums at 0, so what we do, we will eliminate the second first half, right? So we will update the right pointer, else we will eliminate the first half, right? And then okay, and then we will update the left pointer. Okay, okay. And finally, if out from the while loop but it still doesn't have any solution, we can return -1. But this one will never be happens because this array will be, because we will always able to find the minimum value of the given array, right? So let's try. Okay, we have wrong answer. Okay, I think we are missing one condition. We can check if the element at right pointer is greater than the elements at the left pointer, which is the first element. So we can return the nums as left, right? Okay, so now it looks good. Let's try to submit. Okay, accept.